this activity. Let's go. Geometric probability to determine expected value, and we're not pulling any punches. This one is going to be a test of your ability to understand decimal math, area of a circle, and sections of a circle, expected value, probability, and it all wraps up into this one. What a wonderfully excellent last activity for us to do. The dartboard shown has a diameter of 17.75 inches and 20 congruent sections in a circular scoring area. Players score points by throwing darts inside the scoring area, and a dart that lands outside the scoring area scores no points. So it'd be like on the numbers or on the wall, but we're going to assume they're good enough to not miss the circular area of the dartboard. We have some information, and on this page, we need to know two things. But let's read the prompt first, and then we'll go highlight those numbers, because understanding each of these pieces of information and their arrows that overlap an already dark surface, it's going to be hard to see through, so a highlighter will make things more visible. Determine each of the appropriate or approximate probabilities. So we're only doing 1A in this video. Assuming you throw one dart at random at the board, and we'll explain our reasoning and show our work, and we'll round our values to the nearest 10,000th. Probability of getting any score at all. Well, the total area of the dartboard depends on that diameter. So from coast to coast, side to side, the area of the dartboard is pi times radius. That's a diameter. Oh, you're not even seeing it. It's going to be pi times radius. That's a diameter. Radius. So take the diameter and divide by 2, and then squared. Reminder, this 2 is just the denominator of a fraction. This 2 is the exponent of that fraction. So you got to be careful how you're writing them and how you're using them, and know they have different meanings or uses. Now, our scoring area is from the center inner ring, from the very center of the ring out to the edge of the, any part of that green and red checkered circle. So that's called the double score ring. This is the triple score ring. This is your outer ring. This is your inner ring. So this is the bullseye area. And then any of these other checkered are just single scores. Okay? So our double score ring from center out to the edge is 6.7 inches. So our scoring area, that's a radius by the way, is pi times 6.7 squared. We need both of those numbers because with both of those numbers, we're able to calculate the probability of scoring. It's going to be the scoring area divided by the total area. So score area over total area. And I told you we're going to need a calculator, so let's practice this with our TI Inspires. Here's my TI Inspire, and I have all of these decimals ready to go. This is where pi is located on the TI Inspire. Pi, and I press enter to now have it. Times, so parentheses, 6.7, close parentheses, squared. 141.026. This is not floating me to 10,000ths, so I'm going to, you maybe missed this. Pay attention. I'm going to go to Settings and Status, cancel, Menu, Actions. Well, that's not it either. I want to use my buttons. I don't want to use the touchpad, but I guess I'm using the touchpad. So I'm going to click up here on Radian. Ooh, still no. Menu. Actions. It's called float. I want to float this to a little bit larger of a thing. And I'm going to come back to this one, so I'm going to leave that as an explanation I'll show you later. Let me go ahead and finish this. We've got students coming in. You're seeing this in real time. I have pi times parentheses 17.75 divided by 2 quantity squared, enter. I'm going to write both of those down. I'm going to put both of those on this page and in the video. So it's 141.026 divided by 247.45. Both of these numbers are going to make the top and bottom of our fraction, 247.45. Your job is to finish that calculation because we shouldn't leave a fraction with decimals in it. Just do the division and get to a single decimal number result. This has been Page 901. Thank you for watching this video, for liking, commenting, and subscribing. Geometric probability of expected values. And oh boy, we're doing math with all the decimals we've ever tried to use. So I'll see you in the next episode. Thanks for watching.